So here we are with controller number 6 and it's already disassembled. And as you can see, well, the analog stick is completely busted. I just took it off the front like this. And here you can see that this gray part of the analog stick sits now in here, so that's completely broken off. And yeah, of course that has to be replaced. I believe on this controller we had a double stick drift. So even besides the damage, the analog stick was already faulty, and this one is faulty as well, unfortunately. Yeah, when I look at the analog stick, it's completely dirty and grimy, so it's not very surprising that there's a problem with the analog sticks. But we had the other problem with this as well, and that's on the back buttons. So on the LT button and on the RT button. Both of them do not give any response. Yeah, I'm not sure what causes that. I mean, I'm not even sure how this button works. I'm not sure how the response is created. So yeah, I think we should just start with the back buttons. And yeah, let's start by taking them apart and see what it looks like. It's probably a good idea to remove this piece first. Okay, maybe the middle piece first. So that's the middle piece off. And now it should be a little easier to take off these black pieces. So there we go. I think this tape is supposed to be on this button, but now with that removed, it should be easier to get these out. And I'm using a T6 Torx screwdriver to take this out. So in here we just have the motor, and I believe this is magnetic piece right here. I mean, there's a little bit of rust on the motor, but I'm not sure if that's connected to the button fully not working. Okay, I will start by seeing if I can get the motor to work. I'm not sure what the voltage is. I can't find any information on that on the motor. But I will try a 9-volt battery. And the motor seems to be responsive, so I don't think the problem sits in there. It must be in somewhere else. I mean, I believe this is magnetic. Yeah, this is magnetic. I don't know how this is getting registered, if I'm being completely honest. But I think I'm just going to take this heat shrink off and see what it all looks like. Under here. So now we have the heat shrink off, and I believe this is just a magnet. I'm not sure how this is on. I will try and see if I can take it off with some pliers. So it's just a magnet. So I doubt if the problem is in here. I mean, I can try and clean it and see what happens. And it's also strange that both of the buttons are not working. I mean, what's the chance of both of the mechanics of this failing? So it might be... I might need to search this problem in elsewhere on the board, but let's just start simple. It's not really that much dirt coming off. So I doubt if this is the problem. So after reassembling the LB button, I went to test it onto my PC, and unfortunately it was completely the same symptoms. So the back buttons, both of them, gave no response, and the analog sticks were still being drifty, so we had to search the problem elsewhere. So I gave the controller a quick test on the gamepad tester, and yeah, as expected, I think it did not make a difference at all. But what I did find interesting is that when I look at the analog stick, I mean, I do it at stick drift, of course, but both of the sticks are basically like this. So they're completely to the right, even if they are like this positioned. And no matter what I did, it did not. The value did not change on that. So of course, yeah, with stick drift, the stick will never center, but it will move around if I move around the analog stick. But that did not happen at all. And that in combination with the fact that exactly these two buttons are not working, and the fact that the analog sticks are both on the second motherboard, all on this one, that makes me suspect that there's something specifically wrong with this motherboard, and that the first board is fine, especially because I do get a connection to the gamepad tester, and all of the buttons that are on the first motherboard, like the front buttons and the face buttons, are all working fine. So it basically narrows it down to the second motherboard. So I think I will, I will get the second motherboard out of the session, and we can look at that more in depth. And maybe I will put it under the microscope, so we can do a bit of a visual inspection on it. So before we put it under the microscope, let's just go around the Wi-Fi board and see if there's anything of a short on here. Okay, we have a shorted cap on the Wi-Fi board. Not sure if that's normal or not. We have a direct short to ground on the Wi-Fi IC, which that can be very bad news. Unless in the best case scenario it's just this capacitor that is faulty, but I'm not too sure about that. I will get this under the microscope so I can show you it a bit better. Okay, so now we should be recording under the microscope, and here is the Wi-Fi board of the Xbox controller zoomed in a bit. So I have my multimeter and I am in continuity mode. So let me again go over this. So there we go. That's that short. It shows me 0.02 ohms. So I am inclined to believe that this is the main suspect. This is where the problem is, but yeah, the question is, what is the problem on the Wi-Fi board? Is it the main chip? Is it the cap? I mean, it's not really ideal if I had to replace everything on here. And maybe this is normal somehow, maybe. So now I'm reading this cap, and this cap gives me 600 ohms, I think. So that's pretty normal. I will just go over some random caps to see if there's anything else a little bit suspicious. This is also short to ground, and that side is also short to ground. also short. Yeah, I don't know if you can hear this through the microphone, but almost every cap is giving me a dead short. So that makes it very unlikely that one of the capacitors is faulty. But there's indeed a bigger chance that the main chip is faulty of the Wi-Fi board. So that, I mean, it's not impossible to replace, but I will get a donor board of another Xbox controller I worked on in the previous part. I'm not sure if the Wi-Fi board on there is okay, but it's worth trying, I think. So here's the board we are working on right now. Here is the board of the previous part, and it has a red cross to it. So let me see if this gives me a different reading. It's also not looking very pretty, but it might work okay. Okay, hope you can see it. On here the cap is giving, oh, you can still not see it, great. So this is ground, so this side, the right side, ground. The left side of the cap shows me 500 ohms. So this Wi-Fi board might be okay, which is definitely a positive. Yeah, it's also showing 500, 500, 500, yeah. I think it's very likely that the main chip has gone on the motherboard. So on this one. So I think our best option is to replace this. To replace the main chip, since everything is short, but that comes out of it. It's the bigger cap and the smaller caps as well as this cap. I mean, it's basically everything. So since this Wi-Fi board is okay, I think it's my best bet to use that board as a replacement donor for this chip. I will compare the numbers of them. So this one is the possible replacement. It ends on 1447. This one ends on 1336. But if I compare the two motherboards, the Wi-Fi ICs, then yeah, they're basically the same. So I want to replace that. So I think I can use that other board as a donor board for this one. The only thing I need to know is if there's anything is paired on the Xbox controller. Maybe the Wi-Fi chip is married to the main chip. And if that's the case, then I think this may be unfixable. Then I should maybe transplant also the main chip, but I'm not even sure if that's working because the other board was water damaged. So it's definitely no guarantee that that is a good strategy. But if I have figured out if the two are married or not, then the next part we will try to replace the Wi-Fi IC chip. So here we are back again under the microscope, and as you can see, I am ready to take off the Wi-Fi IC chip. I did not really find anything online about the Wi-Fi IC being married to the main chip, so I'm assuming that it's not married. I guess we'll figure it out. But I will now take off this chip, and at least we can see if the shorts on the capacitors disappear after we've removed the IC. So I'm going to apply some flux around the IC, and I will use the hot air gun to take it off. I will try and use a temperature of around 350, 75 degrees Celsius. Airflow speed, I think 4 out of 10 I will try. I do not really want to knock about any of the tiny components. So I want to keep the airflow speed down a little bit. And yeah, let's see how that goes. So I started with removing the Wi-Fi chip under the microscope, but it turned out that due to how close the lens of the microscope is to the actual motherboard, it was kind of difficult to get a good grip on the chip. So I ended up switching over to my normal phone camera so I could remove the chip safely. Okay, so now that they finally have the Wi-Fi chip off, which took more heat than I expected, let's now put the multimeter in continuity mode again. And see if the short is gone. So that this side is ground. We still have short. So it is not the Wi-Fi IC, which does surprise me quite a bit. So the problem must be somewhere else. Let me go onto the main board and see if there are shorts on here. The caps on there are also short, which is, well, not good news. Okay, I just noticed something very interesting. I'm going to take the board out of here and I will give you a close-up on camera. If you focus right here by the analog stick, if you look right here, there's a crack right here. You can also see that the board here is a little bit bent. See, that's where the analog stick also broke off, so probably someone put a lot of pressure on here and it was so much pressure that the board has been broken right here. I'm not sure if there are any fatal traces here, but yeah, it's not looking very good. It shows me 100 ohms. It tells me that it's not really fully connected. I doubt it is the cause of shorts on basically all the capacitors, but it could definitely be problematic. It's not a very strong connection, so it's definitely problematic. So let me see where this goes to. If I turn this around, so that doesn't really want to turn around. So it's right here, turn around. Yeah, it goes under the analog stick, so I'm not sure where it goes. At least the Wi-Fi IC is on the whole other side. So I'm not sure if it has a connection with that. But yeah, given the fact that we do have shorts around this main chip as well, I am very worried that this is going to be a main chip problem. And I'm not very sure if that is fixable. Here you can see the crack in the board. So it's really this side is just bent. Oh, and here as well, I see. See if I can get some good lighting. It's right here. And that does go to some traces, I think, yeah. Oh. That does go to some traces. Yeah, I think even one goes directly to right here, so that may explain why the back buttons are not working. I think that trace is completely broken. Let me clean it up a little bit so it's a bit more visible. But, oh yeah, okay. Yeah, so the crack is right here, and if I turn it around, here's the main chip. There's also a crack right here. And I'm not sure if this is a multi-layer board, but if this is a multi-layer board, then these cracks are not very fixable, I'm afraid. Oh, that is tough. Because if all these layers are shorted, yeah, that means that I cannot. It's not possible for me to separate those layers and then repair them, because if it goes to the board, yeah, then there's nothing I can do about that. No, that sucks. At least I would explain why everything is shorted on here. Then it's very unlikely it's a Wi-Fi problem or a main chip problem, but then it's just multiple layers are just fused together in the board. And I think it is multi-layer, isn't it? I think so. But I might be wrong about that. What I will first do, just for fun, is I will take the board which I have written off in the previous episode, and I will just try it out with this board and see if anything changes in behavior. So after finding all of the cracks in the motherboard, I decided to take it under the microscope one more time and just check how severe some of the cracks are. And yeah, it turned out that on multiple spots on the board there were some serious cracks, some of them almost going to the other side of the motherboard. And that made me decide that this board is probably not fixable and makes very likely a no fix. What I also did is go in the internet and try and find out if the Xbox One controller is a multi-layer board. I did not find any concrete information on it, but I saw that it was very likely that between the upper part and the lower part of the board, that in between, there is a major ground layer, most likely, which that can explain why it took so much heat to take off that one Wi-Fi chip. It definitely took me more than 10 minutes, and I was almost on 400 degrees Celsius, so it's an insane amount of heat. So I think that there is a major ground layer in the middle, and that the upper part of the board with all the cracks in it, that is basically connecting to the ground layer in the middle, which causes all of these shorts on the board. On the Wi-Fi IC, but also about the main chip, you could see that everything was shorted. So yeah, for me, it's simply not worth it. It's not worth to try and fix the traces and then see if it works. I mean, in the end, I'm not my Vince who will do the most insane things to try and get something working. I mean, in the end, I am fixing the controllers to then resell them to someone else, and I'm not convinced that I can give this a reliable fix. So I need to call it at some point. And yeah, especially because, as you can see in the footage, the crack is very close to the main chip and might actually go under it. I'm not sure. But yeah, it's just, yeah, it's not worth it. It's, yeah, unfortunately, I think someone may have rage quit the Xbox controller across the room or something, and it got majorly hit, which then caused the cracks in the motherboard on multiple places, which it makes it a very unreliable fix to fix. So it's simply not worth it. So I will call for this one. I will keep everything around for parts, of course, which is always welcome since I have never worked on Xbox controllers before, so I do not have any spare parts. So that's always a little plus, at least. But yeah, for now, let's move on to controller 7 and see if we can do better on that controller. So here we have controller number 7, or technically one of the controller number 7s. And as you can remember maybe, it's missing the USB port completely. So yeah, that's definitely the first thing we will need to take a look at, I think. As you can see on camera, it seems like the pads themselves are there, still on the board, so I think that the traces themselves may be fine, which is good news. Not sure if anything else was wrong with this controller. Well, I guess not, because I cannot test it. So there may be something else wrong with the controller, but we are not going to find it out until we take it apart, so let's do that right now. So we've just taken these back pieces off, and you can see on the right side there seems to be some sticky stuff on there. It doesn't really feel sticky, but yeah, there is a chance there may have been a leakage of something in here, which, well, that is never good news. But yeah, let's continue with taking it apart. I think this screw post is damaged because the screw is not really doing anything. Okay, now that the controller is taken apart, yeah, the first thing we can notice is obviously this white stuff. Which, in the worst case scenario, that is some kind of water damage caused by maybe the stickiness we found on the plastic pieces. It does not look rusted to me. No, maybe a little bit. If you look right here, I suspect that this may have been worked on. Maybe by someone else. I think because, well, I don't believe Microsoft leave the solder joints like this for factory. That's very unlikely. I mean, the board looks legitimate, I was going to say, but there are a few things very different. I mean, the screws which are used right here are, well, they should be Torx screws as far as I know, but yeah, these are clearly not Torx. And the second motherboard is not held in with any type of screw at all, so I'm not sure if this is a replica or something. I mean, this is the back piece, and it does not really look fake to me, but I don't know anything about Xbox controllers at all, so this may very well be fake. Of course, the button up here is, well, not the usual X button, so yeah, maybe this is a replica. Or maybe this is a outsourced controller or something. Maybe this has been made by someone else than Microsoft, but it is licensed by Microsoft. Not very sure. I mean, if you look at the Wi-Fi board, that does seem to be the same as the one we worked on controller number 6. But yeah, there are some things different, I guess. But I guess this should be able to lift out a little bit at least. I need to desolder it, but I mean, the very first impression is not too bad. I will desolder the motor wires, and then I think I will take it under the microscope after that. There's nothing on this side of the board that would suggest any type of water damage, I think. And it looks pretty clean. This may very well be old flux, I hope, at least. So I don't think for now we need to worry about this motherboard. So let's just only focus on getting this motherboard out. This motherboard, it's a little bit costly right here, I think due to some dirt or something. But yeah, this height, it does not look too bad. I don't see water damage. I don't see any red bends on the motherboard, which would suggest any type of cracking. And here we can see the USB port missing, but the pipettes are intact. At least that is hopeful. We may have a component missing right here, not sure about that. I mean, I doubt it would impact the functionality of it. But yeah, let's take it under the microscope so we can have a better look at what we're working with. Alright, so we're back with a bit of an improvisation type of thing. So that's why we have a bit of this DIY alternative. So I put the screen at a 90-degree angle so I can film it with my phone. I guess it will need to do for now. But anyway, let's go back to the USB port. So as you can see, here we are viewing the USB port. And the first thing I will do is I think I will just measure the pins to see if everything goes to where it's supposed to go. So guys, we will start with the ground. See if it's shorting any of the others. This is ground, so it's perfectly fine. Now let's go to the second pin. This goes to this resistor right here. It's supposed to go there at least. I think I am again on the wrong pad, so that's my fault. It does go to right here, so that is fine. I think. I'm not sure if you have a missing component here. It's definitely possible. I think I will look at one of the spare ports I have, and yeah, if it happens to be that we are missing components, I will place them back before I place back the USB port. And now let's move on to the middle pin, which does go to this resistor, and that's fine. Then this one goes to this resistor, also fine. Then this one goes to this capacitor, I think. Yeah, there we go. Yeah, so that seems fine. This is all ground, I think. This seems broken off, but not really a big deal. As long as you have one ground intact, it should be okay. I will take a look at one of the spare motherboards and see what type of components are supposed to be around the USB port. I mean, here's the motherboard from controller number 6, where we did a little trace repair. Or maybe no, this is the one with the water damage. I think I knocked off some components off of this one, so this may not be very reliable. But and yeah, if we look at pin number 2 from the left, where I did the trace repair, there's no component that sits around D15. So I think that is normal. And also by D14, there's also nothing there, which is pin 5, which goes to the cap. So I don't think there's anything missing there. Last thing I will check is by the resistors. There's also no components right there, so I'm assuming that everything sits in place. Of course, different revisions have different components, but I don't think that anything is missing which will cause the board to not work at all. So let's now just focus on getting the USB port on. So what will I do next? I will desolder out of the ground legs and of the 5 main pins, and after that we should be able to reinstall a fresh new USB port. Alright, so we've cleaned out the ground holes, at least two of them. I think the other ones are actually just flat on this side of the PCB. So I think that means that this is just mounted to a hole with only two ground holes instead of the four which we saw on the previous controllers we worked on. So that's a little bit different, but I think if I can just modify the USB ports I have, and then it should be able to fit perfectly fine. Wires don't get stuck on the ground holes. So let's now grab a new USB port. So here's the USB port. It's supposed to sit like this. So normally we have the two extra ground legs on the back that go on the place where now it isn't tool. So I think we need to cut those off. And I think that we need to extend the metal legs on the front because those are too small. If I try to align them up. Well, maybe it actually fits perfectly fine. Yeah, it seems to line up. So we only need to take care of the two back legs of the USB port. So let me do that. So there we go. So I will fit this in here. This is perfectly fine. You can see that the metal on the back has twisted a little bit, but that's not a big deal. I will just turn the motherboard around. Okay, maybe it is a big deal. I see that the pins are a little bit mangled, so that's no good. So maybe I should have just cut them off instead of twisting it. Alright, well, that's the end of this USB port. Let me get another one. I have dozens of these, so it's not a big deal. But yeah, I will cut them off this time. Alright, so here you can see that I've actually snipped off the legs. I use this, let me show it right here. I use this tool for that. Normally a wire stripper, but you can also cut metal with it, so that's a nice plus. Okay, and let's now install this port on the motherboard and see if that goes a bit better. Yeah, that's 100 times better. And we can still use the back ground pads to connect this to, so that's also nice. But let's start by soldering the two-hole part, and let me also check if this is flush with the motherboard, which I think that is fine. Yeah, that's perfect. Alright, so yeah, let's now solder the two-hole part first, and after that we could do the pins, the 5 pins. So as you just saw on the gamepad tester, the controller is fully working. Well, at least for all the buttons I could test. I tested everything except for the 42 back buttons, and I think I forgot to test the sync button, but I have faith that that is okay. I mean, I guess I could test it with the multimeter. Yeah, that's perfectly fine. So I think that we can call this a fix on the controller. So essentially it was only that the USB port was missing and we just had to resolder it on. So yeah, it's nice to have a bit of an easy fix after all the disasters of the previous two controllers. So what will I do now? Well, I will just give everything a clean. I mean, everything needs a clean. I will do the motherboard on camera and all the plastic pieces will be done off camera. So let's do that now. So there's one more thing I want to do besides cleaning, and that is making the joints on the analog sticks a little bit more pretty, since it looks a little bit rough on some places. So some of the joints don't really look solid. So that may possibly cause some problems in the future. So while we're here, we might as well take care of that as well. I think this looks a little bit better, and I think for the future it's a bit more of a solid connection than the other solid joints that were already there. So now let's continue with the cleaning. So while I'm cleaning the main motherboard now with the USB port, I noticed that although it was working, that this button is on the right side is not very responsive. So it does get recognized by the computer, but here I can feel more of a click, and here, yeah, it's barely existent. And considering I already had a problem with the exact same button on a previous controller, I think that it might be a good idea to just replace that one. If you can hear it through the microphone, yeah, this is much more clickier, so I will quickly replace that. So I think the replacement button fits perfectly fine and flush with the motherboard. So I will reassemble and clean the rest of the parts, and then we will go and test it. So now it's finally time to reassemble the controller. But actually the reassembling you are seeing right now is not the first reassemble of the controller I've done. I reassembled it before, but I noticed a few tiny problems with the controller. And the first one is that some of the legs from the front of the Xbox controller were loose. So some screws were not really going in very nicely and did not fit really well, so I had to fix that with super glue. And secondly, I noticed that the left front button of the Xbox controller that it did not click very nicely, so I already had replaced the right one, and now I decided to also replace the left one, so that both of them have an equal amount of click. I did not really expect it to be a major difference, because with the previous controller where we replaced the right front button, I did not really feel that like there was a big difference between the left and the right side, but here it was very noticeable, so I decided to replace both of them so that they would work perfectly fine in the future. And yeah, after that I could reassemble the controller again and could take it for a test. And the controller did not really have any problems, so all the buttons worked, the vibration worked fine. The controller does light up, so I guess the front X button is not really silver, but it's some kind of translucent button, so the light does come through there. Still not sure whether or not it's a original Xbox controller, because it's so different from the other models that I've worked on. But it seems legit enough, I guess. I mean, even the gamepad tester says Xbox controller, so I don't think it's a fake, but yeah, definitely a revision that I've not really seen before. But yeah, since the test was successful, I guess that is the end of this controller. Luckily, a happy ending for this one. I mean, I needed that after the other two failures. And this also makes the end of this video. So I want to thank you for watching part 3 of the series. Part 4 will be out hopefully before the end of this year. I cannot promise anything. I still need to record the parts. I think we only have 3 or 2 controllers left. And of course the motherboard where I want to put the Hall effect sticks on, but I might make that a completely separate video. Not sure. but you will see that soon enough. And yeah, thank you for watching. I hope to see you in the next video, and have a good day.